So you type something into ChatGPT or Claude and it types back. And honestly, it feels like talking to a person, right? It remembers your name, it follows the thread, it seems to understand. And today, I just want to look at what is actually on the other side of that chat box. Because once I properly understood it, it genuinely changed how I see the whole thing. Let's do one small thing first. Let's say I tell it, my name is Peter. It says, nice to meet you. Then a few messages later, I ask, what's my name? And it says, Peter. So it remembered, obviously. There is someone in there keeping track of me, right? So let's actually go and look at that someone. Behind that friendly chat box is one single thing. We call it a model. Just think of it as one box. And by the end of this, that tiny, it remembered my name moment is going to look completely different to you. So let's start with the only question that matters. What does this box actually do? So, what does this box actually do? Let me just show you because it's almost silly simple. Let's say I hand it a few words. The cat sat on the. It does one thing, it predicts the next word. Here is how it looks at the cat sat on the and produces a probability for what comes next, like mat 60%, floor 12%, couch 9%, and so on, across every word it knows. Then it picks one, usually a likely one, and it sticks it on the end, mat. And here is the thing to notice. It didn't look up a fact anywhere. It just completed the language. What word tends to come next? And that's actually what the name means. A large language model, an LLM. The word that matters is language. It is not a model of facts. It does not have a big table of true things stored inside it. Everything it knows is baked into patterns of language, not looked up records, which, as we will see in a minute, is exactly why it cannot cleanly tell a fact from a plausible sounding one. One quick word, since I will keep using it: token. The model works in tokens, not whole words. A token is just a chunk of text, sometimes a whole word, sometimes a only piece of one. A long word might come in as two or three little chunks. Honestly, just hold on to a token is a little piece of text and you are fine. Okay, so it predicts one token. How does that become a whole paragraph? Simple. It loops. It takes that new, slightly longer sentence, the cat sat on the mat, feeds the whole thing back into itself, and predicts the next token and again. One token at a time. Each one based on everything so far until it decides it's done. That essay it writes you, it never planned it out. It built it up, one piece at a time. So honestly, the closest everyday thing to an LLM is autocomplete. The same autocomplete on your phone keyboard, guessing your next word, just taken incredibly seriously and trained on a huge chunk of basically everything ever written. And it turns out, guess the next word really, really well. Gets you astonishingly far. So that's the engine, not a mind, not a lookup table, a next token predictor run in a loop. Hold on to that one because everything else in this video is just consequences of it. Okay, so that's what inside the box. Now, how do you actually talk to it? And this part should feel familiar if you have ever touched a web service before. You don't really chat with the model directly. You send it a request, an API call. An API is just one program calling another over the network. You send some text, it sends text back. That magical AI thing under the hood, it is literally an HTTP request. The exact same shape as loading a web page. So every single time, the flow is the same. You hand it a block of text, it runs the predict the next word loop over your text and hands you back the result. One request in, one response out. That's the whole interface. Text in, text out. A service you call, same as any other service on the internet. And that's the first quietly big idea here. This AI is not some special magical category of thing. It's a component, a box you send a request to and get a response from. Treat it as a component, and honestly, everything downstream gets a lot less mysterious. Now, this. It just predicts the next word thing, actually explains something people find genuinely confusing. Why does it sometimes just make things up? And worse, why does it sound so confident while doing it? Here is why. And it goes right back to that word language. The model isn't looking anything up. Remember, there is no table of facts in there, no database, no little search happening. It's predicting what text is plausible, what sounds right, based on all the language it learned. And most of the time, what sounds right is right, but not always. So, ask it about, let's say, a person who doesn't exist. It won't stop and say, I don't know. It will just predict a confident, plausible sounding answer, a little biography, and every word of it can be invented. That's a hallucination. It's not lying, and it's not broken. It genuinely cannot tell true from sounds true. And there is a second reason it can be wrong. Its knowledge is frozen. Once a model is trained, all the numbers inside it, its weights, basically everything it learned, get locked in place. So it only knows the world up to when it was trained. That's its knowledge cutoff. Ask it about last week and it just won't know. And it won't admit that. It will predict something plausible anyway. And that same frozenness means it doesn't learn from your charts either. You can talk to it all day, the model itself never changes. And look, I don't want to be dismissive here because it's just predicting words, really undersells what it can do. Predicting the next word at this scale gives you something genuinely powerful. It reasons through a lot, it writes code, it explains things really well. The one honest line to hold is just this: predicting what's plausible is not the same as knowing what's true. Keep that, and it mostly stops surprising you. So, a frozen predictor of plausible language, that's how it can be brilliant and confidently wrong in the very same answer. Okay, back to the mystery from the very start. It remembered my name, but look at what we have actually built: a box that predicts the next word that you hit with one separate request at a time. So, here is the real question: does that box remember our last conversation? And the honest answer is no, not even slightly. Here is the wild part: every single call to that model is completely independent, a total blank slate. The model keeps nothing from the last time you called it. There is even a word for it: it's stateless. Every request is like the very first time it has ever heard from you. So, if it remembers nothing at all, how on earth did it say Peter? Here is the trick, and it's almost embarrassingly simple. It didn't remember, the app remembered, the ChatGPT app, the wrapper around the model. Every time you send a new message, the app quietly grabs the entire conversation so far. Everything you said, everything it said, staples your new question onto the end, and sends the whole pile to the model as one big blank slate request. So when I ask, what's my name? The model isn't recalling anything. It's just reading a transcript that says, my name is Peter, sitting right there in it. A few lines up, it's not memory. It's rereading the whole script every single time. So that is the piece to really hold on to. The feeling of one smooth flowing conversation is completely manufactured on the outside by resending the whole history each turn. It's like handing someone the entire chart on fresh sheet of paper, letting them read it and answer, and then throwing the sheet away every turn. You are not really talking to it. You are reintroducing yourself every single time. Now, you might be thinking, but ChatGPT does remember things about me across charts now. And yeah, some apps have added a memory feature that saves a few facts about you and quietly pastes them back in. But look at what that actually is. It's the same trick, just automated. It's still text being refed into a model that on its own remembers absolutely nothing. And once you see the resending, a very practical thing falls out of it. The longer a conversation gets, the bigger that pile of text is that gets resent every single time. And these models are built by the token, by the amount of text going in and out. So a long chart isn't just slower, it quietly costs more and more. That's not a bug, it's just statelessness showing up on the bill. So, no memory inside the box, just a transcript, resent every turn. The conversation lives outside the model, never in it. So, let's put it all together because it really is one small picture. An LLM is not a mind that knows things. It's a machine that predicts the next token, one piece at a time, text in, text out. Its knowledge is frozen, and every time you call it, it forgets you completely. That's the whole thing. And here is why I wanted to start with this before anything else. Because almost every AI thing you will ever hear about is just a clever way of working around those limits. It has no memory and a knowledge cutoff. So we hand it fresh information right there in the prompt. That's what RAG is. We want a better answer out of it. So we get careful about exactly what text we feed in. That's prompting. We wanted to actually do things, not just talk. So we wrap a predicting box inside a bigger loop. That's an agent. Even the cost of the whole thing comes straight back to counting tokens. Every one of those sits right on top of that little box we just built. So the next time it feels like there is someone in there who knows you and remembers you, there isn't. There is a box predicting the next token, being handed the whole conversation on a fresh sheet of paper every single time. And honestly, once you see it that way, it gets more impressive, not less. That's the part I kind of find wild. That something this simple does all of that. And the next time, we will open the box one more notch tokens and why the model has a budget it can actually run out of.